Okay, I'm going to explain how to use calculator to optimize your time in the exam, in the lab, on the quiz. It's very important to utilize the calculator properly. There are ways of solving the design by hand, manually. Often the most experienced people make mistakes when they do it all by hand. Since we are used to and grown up to utilize the calculator, I'm going to use Casio, and I'm going to show you what to do in terms of calculation. Here is a simple scenario, perhaps a quiz in front of us, and the E is supposed to be ground. The first thing you need to do is to write the equations. So I have, this is E0, 20 volts is equal to the plus side minus the minus side. Plus side is A, minus side is E, therefore this one is going to be 20 volts. And it's going to leave me with three equations. You might be very surprised at the difficulty of a 3x3 system, but you don't have to as long as you know how to use the calculator. Let's write the equation for node B. It's going to be VB minus 20 divided by 22. VB is the biggest voltage in my mind, just for the sake of writing the equation, divided by 10. VB minus VD divided by 15 as equal to 0. That's the nodal equation for node B. Let's do node C. Node C has two components. I need to have two terms. VC minus VB divided by 10. VC minus VD divided by 6.8 as equal to 0. And then when I get to the D, I have three components. I have to see them. Three components. This is also attached to the node D. So it's going to be VD minus 0 divided by 4.7. VD minus VB divided by 15. VD minus VC divided by 6.8 as equal to 0. Often people actually have these equations properly done, and what begins next is going to determine how much time you're going to have in the exam. Are you going to have the common denominator? Are you going to have big numbers such as 700, 10,000, something very odd? Again, you have fractions. How can you do this? It's going to be a huge task if you want to go that technique. But the calculators that are allowed in the exam have the chance to give you, they give you a chance to solve this in a very rather simple approach. The first thing you need to do is to grab the variables in the same order. So I'm going to say VB, then I'm going to say VC, then I'm going to say VD as equal to the constant. I'm going to maintain the same organization, same order. So it has to be the same in order for you to create this, the system. Okay? That much I know. Now the first one. Grab all the VB and tell me what you get. Don't simplify. Don't say 1 over 22 is 0.009. Don't do that. Just 1 over 22 plus 1 over 10 plus 1 over 15. Just leave it like this. Go for VC. You have minus 1 over 10. Grab the minus sign inside so that you are on a safe road. VD, you have minus 1 over 15. And what is the constant? The constant is minus 20 divided by 22. So I'm going to have minus 20 divided by 22 goes to the other side, becomes positive. 20 divided by 22. I don't even simplify this. I just take it and put it as a fraction and leave it on the right hand side. This one, I'm going to grab the VB. It's going to be minus 1 over 10. The VC, I have two components, 1 over 10, 1 over 6.8. The VD, I have one component, and this section is going to be 0 because there is no constant left. So this one is also taken off. Next, this VB, I have only, where is my VB? VB is minus 1 over 15. VC, I have only one VC, minus 1 over 6.8. And when I get to VD, I have three terms. 1 over 4.7 plus, let me expand this, 1 over 4.7, 1 over 15, 1 over 6.8, and do I have a constant? Constant is 0, goes to the other side, and is still going to be 0. It would be really easy to see if you have made a mistake from here to here. And there would be time when you may have to come back to check everything. If you come back, you check the equations, are they correct? Then the question is, did you simplify the design? This step is very easy to check. If you gone and have done a common denominator, you would be in really big trouble to actually check it. So in that sense, that's another reason to enjoy the simplicity of the approach. Now, how many equations do you have? You have 3 equations, 3 unknown. I'm going to use Casio, and I'm not going to simplify anything. I'm going to enter the values as you can see it on the system. I'm going to go in, I'm going to turn on the system. Okay, now here I have mode, another mode, another mode. You can see equation. I'm going to have 1. It is asking me how many unknowns I need. I need 3 unknowns, so that's 3. As soon as I do, you can see A1. What is A1? The system is actually asking you this one. Tell me how much A1 is, B1 is. This is the shape the calculator has in mind. Then you have A2x, B2y, C2z, D2. Then you have A3x, B3y, C3z, D3. This is the shape it's asking you to do. Okay? Let's try this one more time. I'm going to have 3. A1. A1 now is in a bracket. You can actually put them in a bracket if you like. 1 divided by 22. Did I simplify? No. Plus 1 divided by 10 plus 1 divided by 15. I'm done. No common denominator, nothing. You put enter. It simply goes, calculates everything for you. Take a look at the second one. Open bracket, minus 1 divided by 10. Close bracket, enter. C1 is minus 1 divided by 15. Enter. D1 is 20 divided by 22. Enter. The first row is done. We need to go and basically continue the second row and the third row. So let's go. Hopefully that equation is correct. If it's not correct, the idea is you can simply check it. It's really easy checking that later. Minus 1 divided by 10, that would be my A2. My B2 is going to be 2 terms, 1 divided by 10 plus 1 divided by 6.8. Enter. And my C2 is going to be minus 1 divided by 6.8. Enter. And then 0 as my D2. The third row, minus 1 divided by 15. Enter. Minus 1 divided by 6.8. Enter. And then C would be 3 times, 4.7. 1 divided by 15. 1 divided by 6.8. Hopefully I have entered them correctly. So that's enter and then 0. As soon as I do the last one, it's going to tell me how much my x is. My x is 7.29. 7.29. You see, I didn't do anything. 7.29 is going to be my x. As soon as you push another equal sign, just push another equal sign, you see your x becomes 4.56. 4.56. And finally, if you do another equal sign, you simply get the next one. Equal sign, you just push the equal sign, and z is 2.71. 2.71. you can see I have saved perhaps 15 minutes in my time in the examination. Please do take care of the calculators you have. Thank you.